And I'm Nikki. And today we're doing a short video titled The Determination of a Chemical Formula for a Copper Chloride Solution over an experiment that we did in class.
The purpose of this experiment is to learn how to determine the amount of H2O in a sample, also to be able to determine the mass and moles of the sample.
The law of definite proportions states that mole ratios in a compound will be small whole numbers. The law of multiple proportions states that there may be more than one plausible mole ratio for the components with those elements. Determining the mass of the elements in the compound will allow the true chemical formula to be established. The water of hydration in a copper chloride hydrate sample will need to be determined by heating the compound and by measuring the mass before and after heating. Next, a chemical reaction will need to be conducted to produce elemental copper. Then the mass of the copper will need to be determined and measured. Also, next, the mass and moles of the copper and chloride in the reaction need to be recorded and then calculated for the empirical formula of the copper chloride compound.
The procedure for this experiment is to first put on your safety goggles and safety apron and make sure to wear these at all times. Next would be to get all your materials out. First, you will need a crucible with cover. Next, you'll need a clay triangle and a Bunsen burner, and then also a 50 milliliter beaker, a Buchner funnel and filter flask, filter paper to fit the Buchner funnel, and a watch glass.
You want to start by getting the mass of a clean, dry crucible. For our specific experiment, we got that mass as 24.21 grams. Next, we used a micro spatula to transfer our sample into a crucible. And we got that mass with the crucible and the sample as 25.24 grams. As this was our beginning hydrated sample, we took this mass of the crucible and subtracted it from the mass with the sample to get the mass of our hydrated sample as 1.03 grams. Next, we got the mass of the anhydrous sample, which we determined after heating our hydrated sample to drive out the water of hydration, and we got that mass as 24.36 grams.
Next, you need to find the mass of water evolved. For us, during this experiment, it was 0.88 grams. Next, you need to take the mass of your empty watch glass so that you will have a steady amount in grams that you'll be able to go through and subtract later. For us, this mass of the empty watch glass was 88.64 grams. Then, you need to put take the mass of your watch glass with copper. You move this copper using a micro spatula, and for us during this experiment, it was 89.34 grams. Next and lastly, you need to get the mass of your copper. You take the mass of your copper and watch glass and subtract that steady number from your mass of your empty watch glass. And whenever we did that, we got our mass of copper as 0.70 grams.
Lastly, the last step in our experiment, as the name entitles, is to determine the chemical formula for our reaction. The first step that we need to do was determine the charges of all the ions within the compound. First, we had copper, we had chloride, and we had aluminum. We found the charges that we have here, positive 2, a negative 1, and a positive 3, due to their placement on the periodic table. Copper has a charge of positive 2, chloride, negative 1, aluminum has a positive 3 charge. The first compound that we had in our experiment was copper and chloride. We know that because copper has a positive 2 charge and chloride has a negative 1 charge, that there has to be 2 chlorine ions for every copper ion, because for this net ionic equation we need a neutral charge. And then we reacted this with aluminum to separate the two components. And then our products in the end was a 1 copper ion, 1 aluminum ion, and 2 chlorine ions. And also, guys, one last thing to note is when naming the compounds like copper chloride, you need to have the name of the metal plus the name of the nonmetal with the suffix of "ide," I-D-E. So when I refer to chlorine, I'm referring to that element by itself, but it is referred to as chloride when it's within the binary ionic compound copper chloride. Okay, and also when we refer to moles, that's also a type of mass, but when we just say mass by itself, we're referring to the mass in grams. The moles of a sample can be calculated using the grams of the sample, and vice versa. But to note that difference, when we say the mass, we're referring to the mass in grams. In moles, also a calculation of mass. It's just a different type of variable that can be used.
Should you go back?